Hey guys, welcome back. So what we're looking at today is lesson 11. Lesson 11 is equations of all kinds of lines. So we're going to be looking at a lot of lines and the equations for those lines. So let's go ahead and jump right in. So all the same. So we've got this graph here and our information's down here. So what we want to do is plot at least 10 points whose y-coordinate is -4. What do you notice about them? Well, let's plot some y-coordinate or some points with a y-coordinate of -4. So y-coordinate of -4 means, well, this would have a y-coordinate of -4. So would this, and this one, and this one, and this one, and this one, and this one. So would this one. So a point with a y-coordinate of -4 would lie on this line down here through -4. So what we should notice is all these points lie on a horizontal line. So all points lie on a horizontal line that crosses the y-axis at -4. So for number 2, which equations make the most sense to represent all of the points with y-coordinate of -4? Well, x equals -4, does that make sense? No. What about this one where it's telling us our slope is -4, which means we'd be going down and to the right? Nope. What about y equals -4? Yes, that means all our y values are -4, so that means it's going to go on infinitely in any direction. So horizontal lines are going to be an equation with only one variable. A horizontal one will be a y equation, and we'll also look at vertical ones, which will be an x equals equation. So for number 3, plot at least 10 points whose x-coordinate is 3. So come back up here. Here's the color. So if we want x to equal 3, well, here's x is 3 and y is 0. X is 3, y is 1, x is 3, y is 2. All of these are going to have x equaling 3. Every single one of those, x equals 3. So what do we notice about this? They're a vertical line. So all points lie in a vertical line. All points lie on a vertical line that crosses the x-axis at 3. So for our equation, which one do you think it's going to be? If now it's a vertical line and all of our values are 3 for x, it's going to be this first equation, x equals 3. So vertical lines are always going to be an x equals and whatever your x value is for all of them. And then horizontal ones will be a y equals. So now for 5 and 6, we want to take and graph the equation x equals -2 and y equals 5. So x equals -2, y equals 5. So if x equals -2, that's over here, and we're going to take and have a line that goes vertically because it's an x equals, and all our x values have to be -2. So it's going to look something like this. Now, obviously, I'm just making a collection of points. I'm going to attempt to draw the line between them. Make no promises on its straightness. So x equals 2 would be this equation right here. x equals negative 2, I should say. All right, the other one was y equals 5. So that's going to be up above. So right here, y equals 5. So once again, because it's a y equals, it's going to be horizontal. And all of these points are going to be on the line. And it's going to cross that y-axis at 5. And like I said, it's a horizontal line because it's a y equals equation. So dealing with lots of different equations today. Equations is your keyword for this lesson. Equations. All right. There are many possible rectangles whose perimeter is 50 units. Complete the table with lengths L and widths W of at least 10 such rectangles. So if we need a perimeter of 50 units, that means our two measures have to add to 25, if we think about it, because we've got the four sides, two of them being the same. So we have 1 and 24 would be an option because that'd get us 25 plus another set of 25 would give us 50. There's nothing, let's see, if we do 2, we could do 2 and 23. We could do 3 and 22. We can do 4 and 21. We can do 5 and 20. We can do 6 and 19. We can do 7 and 18. And notice I switched those around because either of these are interchangeable. We can switch which one's length, which one's width, and we'll still end up with the same perimeter. We can do 8 and 17. We can do 9 and 16. And we can do 10 and 15. So a whole bunch of different possibilities here. There are more. We could keep this going, but these are a few of those. So looking at those relationships. So now the graph shows one rectangle whose perimeter is 50 units and has its lower left vertex at the origin and two sides on the axes. On the same graph, draw more rectangles with perimeter of 50 units using the values from your table. Make sure that each rectangle has a lower left vertex at the origin and two sides on the axis. So what we're going to notice here is a line is going to form. So we're going to have one, let's see, this is our width is 24 and our height was 1. So here's our rectangle. Our next one was 2 and 23. So we'll have 23 here, go up to 2 and over. All right, so you get the idea. I'm going to take and just do this cornermost point here for the rest of these, just so that way we can still see what this looks like. So we've got this point here and here. Then we have 3 and 22. We have 4 and 21. We have 5 and 20. 6 and 19. 7 and 18. 8 and 17. 9 and 16. 10 and 15. And we can continue this pattern because we know it's going to keep going. When we decrease one, we increase the other. So get these points all plotted so we can see this. this would be if we had done all of the values, all of the possibilities going both directions. So there is our graph. Now, obviously we know we can't really have this topmost point because we can't have 25 and 0 because we need two sides. But notice, what did we just make? We made a line. So each rectangle has a vertex that lies in the first quadrant. These vertices lie on a line. Draw this line and write an equation for it. So to write an equation for this, we know based on what we're looking at, we're doubling, we're taking 2 times our x plus 2 times our y and getting 50 for this. So our equation can look like this. We could also have x plus y equals 25. We can rearrange these so they're in slope-intercept form. So we can have y equals negative x plus 25. We could also have y equals 25 minus x. Those would all be possibilities for a line, an equation for this line. Now, what's the slope of this line? How does the slope describe how the width changes as the length changes? So our slope, how are we going down? We're going down 1 and over 1. Our slope is always attached to our x value. So it's negative x, which means it's a negative 1x. So slope is negative 1. And it means if you take 1 away from the width, we have to add 1 to the length. So take 1 from width, add 1 to length. So there's a relationship here. So we can use tables and we can create relationships from situations and write equations for them. All right, if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.